Welcome to our mathematics class. This is trigonometry part 10, and in today's class we are going to discuss compound angles, right? Compound angles. That means compounding means adding or difference of two angles A plus B, okay, A and B, like that. Okay, for three angles also we are going to see that. On part of that, today our aim is to get the formula for sine of A plus B angle, right? Sine of A plus B is sine A cos B plus cos A sine B. How we have got that, we are going to discuss very clearly. For that, you see, my dear students, you take one angle. This is OX, right? OX. This is OY. Okay, XOY is angle A. Next, YOZ is angle B. You are having here like this. YOZ is B. Totally, these are two angles. XOY, YOZ. This is A, this is B. Like this, we are having like this. Wonderful. Now you take any point P, like this. P, any point you take, you draw perpendiculars to this x-axis here and draw perpendicular to this y-axis like this here, like this, right? Wonderful. And you can draw a line perpendicular, that is parallel to x-axis, that meets here at K, and we denote these symbols as this is P, K, N, like this is Q, like the perpendicular here N. From N also you draw the perpendicular like this. From N also you draw. It is nothing very simple, my dear student. You draw perpendicular from P to x-axis, from P to y-axis, this Y, okay, OY, like that. From N also you draw perpendicular such that you got a nice rectangle like this. You name them these things like this, right? Wonderful. This is the thing what we have got here. Once we got this, we need to find now sine of A plus B angle, like this. Sine of A plus B angle, right? And here you see, as I told you, this is perpendicular to this Y. And here you have drawn nice rectangle we have got here like this. And one more thing I want to tell you here, you observe these triangles, right? These triangles, which triangles? LOQ and PQN. For this, this is vertical opposite angles, they are equal, and this is 90 degrees, this is 90 degrees here. Okay, by A similarity, this angle A means this angle will be A. You are going to have this angle is nothing but A, like this, right? Because this is A means this is also will be A. Now how we will be getting sine of A plus B? Now you see, my dear students, sine of A plus B is if you consider this triangle, like to consider, okay, POL, in triangle POL, like this, in triangle POL, sine of A plus B is equal to, you know, that opposite side by hypotenuse. This is what PL by OP, like this, right? PL by OP. And that PL by OP, we've written it as, right, my dear students, we can write this because here K we are having here LK, like this. You have see here LK plus KP by OP, we can write LK plus KP by OP. This is what that step. Now I told you that this is a rectangle we have got here. LK, in that place of LK we can replace by MN, like this. That's why we have got it as LK means MN plus KP by OP. Now you split that, you write this as MN by OP. MN by OP plus KP by OP, you can split like that. Now this is, you can write as MN by ON into ON by OP, like this, right? You can just multiply and divide it, and here also KP by OP, you written KP by PN into PN by OP. Now this MN by ON, if you consider this triangle OMN here, if OMN, if you consider in this MN, okay, MN by ON, opposite side by hypotenuse, that is nothing but here you have angle A, sine A will give you MN by ON. That's why MN by ON place you written sine A. And ON by OP, right? ON by OP. Here you see here what you are having here, ON is this, right, by OP. This is the adjacent side for this triangle P and O, right? That's why, and the angle is what for this B. Therefore, ON by OP will give you adjacent side by hypotenuse. That will give you cos B, like this. Wonderful. Next, plus KP by PN. Here you see KP. I told you already this angle is A. KP by PN. KP is the adjacent side for angle A here. Adjacent side for the angle A. And PN is what? The hypotenuse. Therefore, KP by PN will give you cos A. Okay, and Pn by OP we are having finally. This is what Pn by OP. For this triangle, angle is B. For this opposite side is Pn. Pn by OP is nothing but sin B. Therefore, finally we have got sin of A plus B is equal to sin A cos B plus cos A sin B. Very nicely we have got this particular derivation sin of A plus B. In further, dear students, you have to remember this as sin of A plus B, how we have got it as sin A cos B plus cos A sin B. This is a very, very important compound angle formula, right? You have to remember this, and this is the proof how we have got. From this we are going to get sin A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B, cot A plus B, cot A minus B, like different formulas we are going to get it. Now we have the second formula, sin of A minus B. This we can easily achieve by sin A plus of minus B, by taking like this, A plus of minus B, by taking like that, right? We can get this formula. Now only we have, in the place of B we have taken here minus B. Now only we derived sin A plus B formula. Let us use that, sin A cos of minus B plus cos A sin of minus B. Now this is sin A, cos of minus theta become cos theta. Therefore this become cos B plus cos A. You are having here sin of minus B becomes minus sin B, because sin of minus theta become minus sin theta. Now this become sin A cos B, okay, and plus into it is under multiplication, minus cos A sin B. Like this we have got this wonderful result. Sin A minus B we have got, therefore like this, sin A minus B equal to sin A cos B minus cos A sin B, right? This way we have got this second formula. Now we have the third formula, cos A plus B. How we are going to get it? That is, actually we have to prove cos A cos B minus sin A sin B. I am taking here because already we proved sin of A plus B. I will take sin pi by 2 plus of A plus B. You see, sin pi by 2 plus theta, that become cos theta. In the place of theta you are having now A plus B here, like this. Now sin pi by 2 plus of A plus B becomes sin 90 plus A plus B, that become cos A plus B. Sin 90 degrees plus theta become cos theta, because it lies in the second quadrant. Now this pi by 2 plus A, I am making it this as one group plus B as another element, like that. Now let us apply, okay, the sin of A plus B formula. Already we have derived it. In the place of A you are having pi by 2 plus A, and in the place of B you are having B. Therefore sin pi by 2 plus A become, this becomes sin A. Sin A means in the place of A you are having sin pi by 2 plus A, and cos B plus cos A. Cos of, in the place of A you are having pi by 2 plus A, cos A sin B, like this, right? We have written, just to be replaced A by pi by 2 plus A. That is what we did here, like this. Now this becomes sin pi by 2 plus A, sin 90 degrees plus A become cos A cos B, right? And cos pi by 2 plus A, that become minus sin A, because in second quadrant cos become negative, minus sin A sin B. We have got wonderfully like this. Therefore we have got a cos A plus B. We have proved this as cos A cos B minus sin A sin B, like this, minus sin A sin B. Cos of A plus B become cos A cos B minus sin A sin B. In this way wonderfully we have proved the third one, cos A plus B formula. Now the fourth one, we need to get cos of A minus B. Let us use this one. We write it as cos of A plus of minus B, like this we write. A plus of minus B, that become cos A minus B only. We can use nicely cos of A plus B formula. Now only we have derived this one. This we can write it as cos A cos B. In the place of B you are having minus B. Cos A cos B minus sin A sin B. In the place of B you are having minus B, like this. Now this become cos A cos B. Right? Sin of minus theta become minus sin theta. Sin of minus B become minus sin B. That's why minus into minus plus. This is now plus sin A sin B, like this. Wonderfully, we have got now the formula. Therefore, cos of A minus B is equal to cos A cos B plus sin A sin B, like this. Cos of A minus B become cos A cos B plus sin A sin B. In this way, we have got this wonderful problem, right? The result. Now we have the fifth one. Tan of A plus B is equal to what is tan A plus tan B, right? Tan A plus tan B by 1 minus tan A tan B, right? 1 minus tan A tan B. This is what we require to prove. For this, how we will take, you see dear students, tan of A plus B. You take tan of A plus B. Already we know that tan means sin by cos. This is sin of A plus B by cos of A plus B, we can write like this. Right? Once we have got sin of A plus B by cos of A plus B, this you can write it as sin A cos B plus cos A sin B, like this. Cos A sin B divided by, this is now cos A cos B minus sin A sin B. Minus sin A sin B. Sin A cos B plus cos A sin B by cos A cos B minus sin A sin B. Now what we do for this is, we divide numerator and denominator by cos A cos B. You see, we have taken the numerator, you divide it by cos A cos B. And also the denominator, you divide it by cos A cos B. That means you just multiplied and divided by cos A cos B. That is allowed in mathematics. Just they will be get cancelled. But we want to take this in different form. That's why we have taken this like that. Now see what thing we are going to do. This is now sin A cos B by cos. We will split this now. This become now sin A cos B. Sin A cos B by cos A cos B. This is now cos A cos B. Plus cos A sin B. This is now cos A sin B by, this is also cos A cos B, like this. Cos A cos B. This whole thing divided by cos A cos B. Right? Cos A cos B by cos A cos B, like this. Minus sin A sin B. Minus sin A sin B by cos A cos B, like this. Right? Now I think there are some terms we can cancel. This cos B will cancel, and here cos A will cancel, and here cos A cos B total, that will be cancelled. Sin A sin B by cos A cos B. Now you see my dear students, sin A by cos A, this become tan A, and this is tan B. You will get sin B by cos B, this one, and here this is totally cancelled. This is 1 minus sin A by cos A, that become tan A, and sin B by cos B become tan B. Wonderfully we have got now this formula. We have taken left hand side and we have got this as right hand side, like this. Such that right, we have got very easily this derivation. Tan of A plus B become tan A plus tan B by 1 minus tan A tan B. We have got it nicely. Please observe. Here while we are doing this tan of A plus B, here the conditions we have something. A, B, A plus B, none of them are odd multiples of 90 degrees. That means A, B, A plus B should not be odd multiples of 90 degrees. If they are odd multiples of 90 degrees, what happens is tan become not defined. Then tan not defined means this formula itself does not exist. We have to be very careful such that A, B, A plus B, they are not odd multiples of A, comma B, comma A plus B. They all should not be odd multiple. This is 2n plus 1 times of pi by 2, where n belongs to z. This is very, very important. Right? Because if they are odd multiples of 90 degrees, what happens is they become undefined, then the formula itself does not exist. That's why we are writing this. Okay, now we have the sixth one, tan of A minus B, right? This tan A minus B equal to tan A minus tan B by 1 plus tan A tan B we are going to prove. In this case also, A, B, A minus B, none of them are odd multiples of 90 degrees. Same logic applies here also. A, B, you are having here A minus B. They are not odd multiples of 90 degrees. If they are odd multiples of 90 degrees, what happens is tan will become undefined. For undefined thing, you cannot get the formula infinitely. That's why these conditions are true. Now, how we are going to prove this under these conditions, right? We already proved, okay, see here how we are going to do the proof of this, right? Tan of a minus b, you can write it as tan of a plus of minus b, like this, right? Wonderful. Now this is equal to, you can write this as, right, you know already you derived tan a plus b formula. This is now tan a plus tan of minus b tan a, and 1 minus tan a tan of minus b, like this, tan of minus b, right? Now this becomes tan a, and tan of minus theta become minus tan theta. That's why this is now tan a minus tan b divided by, and here tan a into tan of minus b, minus into minus plus, this become 1 plus tan a into tan b, 1 plus tan a into tan b. This is nothing but, now you have got tan a minus b is equal to, okay, you have taken here the left hand side and you got it as right hand side, right? Wonderfully we have got now 6 formulas. Sin, okay, sin a plus b, sin a minus b, cos a plus b, cos a minus b, tan a plus b, and tan a minus b. We have got 6 formulas very nicely. See, now we have cot of a plus b formula, the 7th one, cot a, cot b minus 1 by cot b plus cot a. And here also a plus b are not integral multiples of pi, right? Because if they are integral multiples of pi, what happens is, okay, cot a, cot b, cot a plus b, they will be undefined, okay, and they will be undefined means you cannot get, we have to get a finite. That's why these conditions supposed to be true, right? Now you see how we are going to do this proof, right? Like in tan a plus b, this you write cot a plus b, you write it as cos of a plus b by sin of a plus b, like this, cos of a plus b by sin of a plus b, right? And this is equal to cos a cos b minus sin a sin b, that already we proved, minus sin a sin b, like this, right? Divided by sin a plus b, this is sin a cos b plus cos a sin b, like this, cos a sin b, right? Fine. Now what you do is you divide numerator and denominator by sin a sin b, right? You divide numerator and denominator by sin a sin b. This is what you see here. You are going to get this, you are dividing cos a cos b minus sin a sin b divided by sin a sin b, here like this, sin a sin b, and this also here. Now you have sin a cos b, sin a cos b plus cos a sin b, like this, whole thing divided by sin a sin b, like this, right? This is what we did here now, like this, right? After doing this, what we do is we will split this, right? Since there is no space, we write here, we split now. Once you split, this is now cos a cos b by sin a sin b, like this, minus sin a sin b minus sin a sin b divided by sin a sin b, like this, whole thing divided by, now sin a cos b by sin a sin b, like this, sin a sin b plus cos a sin b divided by sin a sin b, like this, sin a sin b. This is what we have splitted each and everything now, like this. Now we will see, is there any possibility of cancelling the terms, something like this. Okay, here now we have got cos a by sin a. That means we can write as cos a by sin a, we can write as cot a. Cos b by sin b, you can write it as cot b minus sin a sin b, this they will be cancelled, and we have got it as minus 1 divided by, here sin a sin a will be cancelled, this become cot b, we have got cos b by sin b become cot b plus here sin b will be cancelled and this become cot a, like this. Okay, and this is what the right hand side part you have taken, left hand side, and you have got nicely the right hand side part. That means you have got now the seventh one. Cot of A plus B become cot A cot B minus 1 by cot B plus cot A. This become true when A plus B are not integral multiples of 180 degrees, right? Now we have the eighth formula, cot of A minus B. How we are going to achieve this? And here also this cot of A minus B is what? Cot A cot B plus 1 by cot B minus cot A. Here A minus B are not integral multiples of pi. That means they are not integral multiples of pi. As you know the reason, if they are integral multiples of pi means they will be undefined. Once they are undefined, this formula itself does not exist, right? Now how we are going to do this proof? You see, my dear students, the left hand side we are having here. This is now cot of A minus B. I am going to take this A minus B as cot of A plus of minus B we will take like this. And now only we derived cot of A plus B formula. And this become cot A cot of minus B, right? Plus 1 by cot B. Cot B means cot of minus B minus cot A, like this we have like this, right? Fine. What we do here is, this is now minus cot of minus theta become minus cot theta. That's why minus cot A cot B plus 1 whole thing divided by, this is now minus cot B minus cot A you are having here. I think you can take minus sign common here. Minus if you take common here, this become cot A cot B minus 1 by minus if you take common cot B plus, okay, yeah. Now if you take a common here, what you are going to get? Right, 1 second. Right, my dear students, here cot of A plus B is cot A cot B. This is what? Minus 1 here, right? Here also it is minus 1 here, right? Once it is minus 1 and this is now plus here, it is plus here. Now let us take common here, then it become plus here like this. And minus sign if you take here, you are going to get, this is now cot B minus cot A like this. Now this minus minus will be cancelled. Then you have got the formula cot A cot B plus 1 by cot B minus cot A. Okay, it is very simple, my dear students. How we did is cot of A minus B means we written cot of A plus of minus B. This become cot A cot of minus B minus 1 by, because you applied this in cot A plus B formula. And this is cot of minus B plus cot A. You know, cot of minus B become minus cot B. We have written this and we have got like this, and we took minus sign common and simplified. We have got this nice elegant formula. Now we have another important result, very important in doing the problem. Sin A plus B into sin A minus B is equal to sin square A minus sin square B. That is nothing but cos square B minus cos square A, right? How we are going to do this? You see, my dear students, the sin A plus B, left hand side, sin A plus B, you know that now only we derived, that is sin A cos B plus cos A sin B. This is now cos A sin B. Sin A cos B plus cos A sin B into, this is nothing but now sin A cos B minus cos A sin B, like this, right? This is what we have got. This is something like A plus B into A minus B, right? A plus B into A minus B. This we can write it as, this is now sin A cos B, right? This is actually A plus B into A minus B. This is now A square minus B square. This is sin A cos B whole square minus cos A sin B whole square, minus cos A sin B whole square, like this. Now this become, you can write it as sin square A cos square B minus cos square A sin square B, like this you can write, right? But we have this result, the first result is purely in terms of sine. That's why let us try to convert that into sines, right? Here you see, we write, this is now sin square A, cos square B, we write it as 1 minus sin square B, like this, minus cos square A, we are having that, we write it as 1 minus sin square A into sin square B, like this. Now this becomes sin square A minus sine square A into sine square B. Minus 1, minus into minus, plus sine square A sine square B, like this. Now this minus sine square A sine square B plus sine square A sine square B will be cancelled. And here you are having here minus 1 means, dear students, here minus of sine square B, right? And plus sine square A sine square B, plus sine square A sine square B. Wonderful. This and this will be cancelled. Now you have got wonderfully sine square A minus sine square B. You have got wonderfully the result sine A plus B into sine A minus B as sine square A minus sine square B. You have got it like this. Now this sine square A minus sine square B we have to get in terms of cos. That is now cos square B minus cos square A. You see this what we have got, this sine square A minus sine square B. Let us convert purely into cos. Right? This sine square A we can write as 1 minus cos square A minus, this is 1 minus cos square B we can write. Now this becomes 1 minus cos square A minus 1 plus cos square B, like this, right? And this will cancel, thus become now cos square B minus cos square A. See the second result also we have got wonderfully. This is now cos square B minus cos square A. Therefore sine of A plus B into sine of A minus B equal to sine square A minus sine square B. And that is also in terms of cos, you have got cos square B minus cos square A. Okay, wonderfully we have got this result. Now dear students, so we have the 10th result, that is cos A plus B into cos A minus B. That is now cos square A minus sine square B. That also is equal to cos square B minus sine square A. How we are going to prove? Let us do this also. Right, you take the left hand side part here. Once you take the left hand side part here, right, this is cos A plus B. This is now cos A cos B minus sine A sine B, like this, minus sine A sine B into cos A minus B. That is now cos A cos B plus sine A sine B, like this, plus sine A sine B, right? Now this is also something like A minus B into A plus B formula. Now this becomes A square minus B square. This is what? A square minus B square. Now this is equal to, what we can do is cos A cos B whole square minus sine A sine B. Sine A sine B whole square. Like this we can write this. Now this becomes cos square A cos square B. Like cos square A cos square B minus sine square A sine square B. Like this. Right? Wonderful. Now we have to get this as cos square A minus sine square B. That's why what I do is here cos square A into this cos square B, I write it as 1 minus sine square B minus this sine square A, I write it as 1 minus cos square A, right, into sine square B, right. Once we write like this, now this become cos square A into 1 is cos square A minus cos square A sine square B, like this. And this is now minus sine square B, minus into minus plus cos square A sine square B you have got here. Now here this minus cos square A sine square B plus cos square A sine square B will be cancelled. Once it is cancelled now like that, now you see my dear students, right, we have end up with a nice thing like what we have got. This is now cos square A minus sine square B, like this. Right, cos square A minus sine square B. Wonderfully we have got this. Now this we have to prove another one. This is the first one we have got here. Now another one we need to prove. What we have got is here now cos square A minus sine square B. That once again we convert into the second form. How means this cos square A you write it as 1 minus sine square A. 1 minus sine square A minus sine square B you write it as 1 minus cos square B. You write like this. Now this becomes 1 minus sine square A minus 1 plus cos square B, minus into minus plus cos square B. Now this 1 and minus 1 will cancel. This become now cos square B minus sine square A, like this. Cos square B minus sine square A, right? In this way, we have got the 10th beautiful result like this, my dear students. These are very important. You have to write clearly in your notes such that we are going to do all problems based on this. These are compound angles concept you have to do. Okay, the problems based on this. If you don't know these formulas, you cannot do a single problem of it. In this video, totally we are discussing the results. Now we have the 11th result, tan of a plus b into tan of a minus b. Okay, that we are going to get this, and under its conditions, like what are the conditions to be satisfied for tan. Under those conditions we are going to have. How we are going to prove that? You see, my dear students, this is tan a plus b. You know that you write it as tan a plus tan b, tan a plus tan b by 1 minus tan a tan b, right? This is what tan a plus b formula. This into, right, tan a minus b, tan a minus tan b by 1 plus tan a tan b, like this, 1 plus tan a tan b. Now the numerators and denominators you multiply separately. This is now a plus b into a minus b. Denominator also a minus b into a plus b. This become now tan square a minus tan square b, because this is something like a plus b into a minus b, and here also a minus b into a plus b. You just multiply them like this respect to numerators and respect to denominators separately by the formula a plus b into a minus b. That gives you a square minus b square. That become now 1 minus tan square a tan square b. That beautiful way we get this result like this. Now we have the result, next one, the 12th one. We have cot a plus b into cot a minus b is equal to cot square a cot square b minus 1 by cot square b minus cot square a. How we are going to do this also? You see, my dear students, the left hand side you write cot a plus b form. Now only we derived this cot a cot b. This we derived that as cot a cot b minus 1 by cot b plus cot a, right? Into this is nothing but cot a cot b plus 1 by cot b minus cot a, like this, right? Here also something like a minus b into a plus b apply. Here also a plus b into a minus b apply. Now a square minus b square, that nothing but cot a cot b whole square minus 1 by cot square b minus cot square a. This is nothing but cot square a cot square b minus 1 by cot square b minus cot square a, right? This is what you have taken the left hand side part, and you got the right hand side part like this. Like this we have got these wonderful results. These all results you are going to do and apply in your respective problems. Okay, thank you for watching. Thank you, dear students.